Hello, this video is to assist you in creating a histogram in probability and statistics class. Now, it is possible to make them by hand. The problem is sometimes it just gets a little difficult thinking about, okay, my classes look like this. Sometimes we forget about what histograms even look like. The good news is the calculator can, to some extent, do that for us. So the prerequisite for this class, for this video rather, is to get data put into L1. I still have my strikeouts, my Adam Wainwright strikeout data from my previous video. So that is what I'll be using to make a histogram. Now, on our stat exams, oh my goodness. On our stat exams, our questions to create a histogram always give the first class. So I'm already given a class of 20 to 59. So I'm just gonna put that in. It's not actually subtraction. I'm just gonna put that in to remind myself my first class is 20 to 59. If we press the blue second key and then press all the way at the top left button, Y equals key, we get this stat plots screen. And stat plots is where we need to go if we want to represent our data in the calculator. Right now I have it on. You might have it as off. So to turn it on, make sure that the flashing cursor is over the on key, and then press enter so that on is in solid black. Go down to the type menu, and we want to select the one that looks most like a histogram. So this one is for a scatter plot. This would be time series. Our histogram lives here. This is for a box plot with outliers, a box plot without outliers, and I believe this might be an ogive. We never talked about that in class. So I'm going to select enter on the histogram. Make sure your X list is L1. Frequency should be 1, and the color doesn't matter. Pick a good color that you like. To get this on our screen, we are going to go to the top row of keys again, and I'm going to select that middle key, which is zoom. And there's a lot of different options here. A lot of these are used in algebra, but the one we are interested in is number 9, zoom stat. You can either press all the buttons required, the down keys required to get down to number 9, or if you just press zoom and then 9, like the physical number on the keypad, that will also engage zoom stat. Now here's the problem with zoom stat. Zoom stat is not always going to use the classes that we need when either you're given a first class. Sometimes zoom stat will also just make really, really weird classes. And so we need to kind of force the calculator to use the classes we want. So if we press trace is another key at the top row here. We can kind of view what the calculator has as their classes. So the calculator has anything from 20 to 59.8, or just under 59.8 in the first class, 59.8 up to 99.6 in the second class, and so on. Like I said, we need to force the calculator to use our classes instead. What that is going to require is some sense of what our class size is. So if I do the math here, if I do 59 minus 20, we get 39, actually positive 39. The problem is when we do our histogram classes, they're actually inclusive of both of these numbers. So both 20 counts and 59 counts. So whatever your top boundary is minus the lower boundary, you actually need to add 1 to that. So our actual class size is 40. If we've already done zoom stat, then the window key is just to the left of the zoom key. Go ahead and click the window. We want this X min button to be our minimum X value. And our minimum X value is indeed 20. So I'm going to leave it just like that. Our X max value We'll just leave that as is for now. And then this is really what we're interested in here. SCL, this stands for the scale of the x-axis. Our previously calculated class size, this is what we're going to put into the x scale operation. So we found that our class was size 40, so I'm going to put 40 into the x scale. If I don't click zoom stat again, because zoom stat will reset this. It will turn it back into 39.8 or whatever it was before. But instead, click graph. And now if I trace along my graph, I should have all of my class boundaries as I want them. This is going 20 up to 60, which is to say 20 to 59. This is going 60 to 99, 100 to 139. 140 to 179, and 180 to 219. If I look back at my data, I do not believe I had any data points greater than 219. And so this is actually the complete representation of my data. I don't need anything over here. Now, I have had other data sets where the data kind of spills over. So let me add a data point here. We'll pretend like this was in the initial data set. Let's say there was a 225 in there. Now when I go to graph that, I am missing that upper boundary. It is not on my screen. So you're just going to go back to the window screen if this happens. You're going to go down to X max and set that as whatever you need it to be. So I'll do 260. And now I can kind of see the edge. Maybe we'll try 270, not 40, 70. And now I can really see the edge. Again, with the trace key, you can view the boundaries. So 20 to 60, 20 to 99, 60 to 20 to 59, 60 to 99, 100 to 139, and so on. Remember the scale on your histogram goes just by the lower boundaries. So if I were to transfer this onto my paper, I would give this x-axis an initial number of 20. We're starting at 20. And then it just follows the minimum boundaries. So this would be 20. This would be labeled as 60. This would be labeled as a 100. This would be labeled as 140. This is labeled as 180 and 220. Remember, in addition, you also need a frequency scale on the vertical axis. So I hope this helps with constructing your own histograms. Thank you for watching. I will see you next time.